Okay, so in the last class we had done about light. We had done refraction of light. Had we completed with the lateral displacement, that is refraction through a rectangular glass slab? Just 1 minute. 1 minute, 1 minute. Uh, Once. Okay. So am I audible now? Okay. So in the last class we did about the refraction of light. Did we completed about the rectangular glass slab? Just 1 minute. Yeah. So yeah, पहले learn लगता है. Just 1 minute. 1 minute. ते काय कुठे मस्ती करायला अलाउड करले ये बात कहूं अब यार क्लास डिस्टर्ब अब देखो अब जुठे वो के पीट दिए जुठे नचा देते Okay. Now check if I'm audible. Am I audible now?
Yes.
Okay.
Yes, sir.
Okay, let's continue. Sorry. Okay. Can you all of you turn on your cameras? Let's start now. In the last class, we had done about the refraction of light. And during that refraction of light, so what all we had done? We had done some laws of refraction. So anyone can anyone recall the laws of refraction? Can anyone recall laws of refraction? Aryan, what were the laws of refraction?
1 minute, sir.
Yes.
Sir, incident, refracted and normal rail, all lines same plane, sir.
Okay, all lines same plane and
And sir, that ratio of sine of angle of coincidence to the angle of sine of angle of reflection is a constant and
okay,
equal to k, sir.
equal to the refractive index. Okay.
Refractive
We
index.
have, yes, the ratio of, we done, the ratio of sine of angle of incidence to the angle of refraction is a constant. Ratio of sine of angle of incidence to the sine of angle of refraction is a constant and is equal to the refractive index. This is the same as the refractive index. We had studied about the refractive index. I had told you what the refractive index stands for. The refractive index is given by the formula. See, the refractive index is given by C by V, where C represents the speed of light in air or vacuum, where Vm represents the speed of light in the given medium. So the refractive index of any medium is given by C by V. Suppose I want the refractive index of water. So the refractive index of water will be given by the formula N equals C by VW, means the speed of light in water. N represents the refractive index. So this is the refractive index. Now what the second rule says, it says that if you find the sine of angle of incidence divided by sine of angle of refraction. So this is a constant, and this constant itself is equal to the refractive index. That means sin I by sin r is equal to the refractive index. And so refractive index can be obtained by two methods. Either you obtain sin I by sin r, or you obtain C by V. So by both these methods, you can obtain the refractive index. The refractive index is equal to C by V, or it's equal to sin I by sin. Both will be the same. So the two laws of refraction, they hold for all the surfaces, all the angles, except when the angle of incidence is 0 degree. If you have the angle of incidence at 0 degree, so that is the case where the laws of refraction, they are not defined. Where you will not find sin I by sin r is equal to the refractive index. Else at all the angles of incidence, you will find this sin I by sin r equal to the refractive index. This rule is also called as Snell's law. We also call it as the Snell's law. Now, we had seen that how the refraction of light takes place when light enters from a rarer medium to a denser medium. So the ray of light, it bends. When the ray of light moves from a rarer medium to a denser medium, so it bends towards the normal. And when it moves from a denser medium to a rarer medium, then it bends away from the normal. So here you get some rarer medium. Here you have a certain denser medium. And if you have the ray of light traveling from the rarer medium towards the denser medium, the ray of light bends away from the norm, bends towards the norm. So in the meanwhile, also learn how to draw the normal. Normal is at the point of incidence. You have to make 90 degree. At the point of incidence, make a line which stands 90 degree or perpendicular to the refracting surface. So this is our normal. Let's mark it as N. ON is the normal. This angle is the angle of incidence. This one is the angle of refraction. Okay. This is your incident ray. This is your refracted ray. And hence you get this. So for this, if suppose here you have some speed C, here you have V, and then you will get the refractive index as C by. Now, it will also talk about the relative refractive index here. But before that, today let's discuss about the rectangular glass slab. For that, for that. You have a rectangular glass slab. So for the rectangular glass slab, what we observe, how does the refraction occur? So you observe here, let's take a glass slab and we take a ray of light which enters the glass slab obliquely. Obliquely means at a certain angle which is not 90 degree. So we take a ray of light which enters here, comes from air into this glass slab. So outside the glass slab, everywhere you have air. Here you have air. Here you have glass. So we observe that the ray of light is entering through the glass slab. Now, at this point, at the point of incidence, we will draw here the normal. So let's draw here the normal. So here is the normal. As the normal makes 90 degrees, so it makes 90 degree with the surface. Now, the ray of light should be going straight as per the rectilinear propagation of light. The ray of light should be going straight like this as it was going earlier. But since the ray of light is moving from a rarer medium to a denser medium, we will observe the ray of light to be bending. We will observe the ray of light to be bending away from it. So in this way, you will have the ray of light, and this ray of light will now bend towards the normal. So this ray of light bends towards the normal. Instead of going straight, it bends towards the normal like this and reaches the second refracting surface. So here I observe this first refracting surface AB. The first refracting surface AB. At the first refracting surface, the ray of light was traveling from from a rarer medium to a denser medium, and hence we observed the ray of light to be bending towards the north. When the ray of light reaches the second refracting surface, now here another refraction will take place. Before that, let us mark all the angles. So I can mark this angle as the angle of incidence and this one as the angle of refraction. I expect everyone is making the diagram. Okay, you should also try to make the diagram along with me. So along with me, try to make the ray diagram. Now at the second refracting surface, the ray of light it bends again. So here again we draw the normal. Now the ray of light which was supposed to go straight. This is the green light. If you observe the green light which was traveling through the glass slab. So this green light was supposed to go like this. It was supposed to go like this. But due to the change of the refractive index, due to the change of the medium, since now it is traveling from glass to air, so we will observe that there will be a bend of light. So in which direction will the ray of light bend again?
Away from.
Away from the normal. So now we will observe this green light to be bending away from the normal. So let's draw again by the blue light. So you will get here a ray of light that travels away from the normal. So you get a ray of light traveling away from the. Now, an important thing we observe here. See, this was the incident light that we got. And you have finally, this was the incident one. See, this I have drawn the path through which the ray of light was incident. And this is the final one, how the ray of light actually comes out. This is where the ray of light was expected to come. This is where it is actually coming. Okay. So we observe some lateral distance between these two. There is some distance between these two, and this distance between the two lines is called the perpendicular distance between them is called as the here we observe some perpendicular distance between these two lines, and this perpendicular distance is called as the lateral displacement. We observe that these two lines, they are displaced by a certain distance d from each other, and this distance between them is called as the lateral displacement. So we mark here d as the lateral displacement. D is the lateral displacement. Now, so can you tell me what will be the value of this angle? I want the value of this angle.
So will it be equal to R?
Yeah, this will also be equal to R due to alternate angles. These two are
Yes.
alternate angles, so it should also be equal to R. And this outer angle with which our final ray comes out, this is called as the angle of emergence. We mark it E, which we call as the angle of emergence. So here E is the angle of emergence. And for a glass slab, you have angle of incidence is always equal to the angle of emergence. The angle of incidence is always equal to the angle of emergence. So that is why you will get your incident ray and emergent ray parallel to each other. So in the case of glass slab, we observe that there is a lateral displacement. Okay. And this lateral displacement between the two light rays is dependent on certain factors. Questions are asked from this one that what are the factors on which the lateral displacement depends. Okay. So we have seen a number of questions being asked in a number of sample papers. You will find this question that the factors on which lateral displacement depends. So what are the factors on which the lateral displacement depends? The lateral displacement of the ray of light, it depends on the refractive index of the slab. It also depends on the thickness of the slab. So you must note down that what are the different factors on which the lateral displacement depends. That is the distance between the two light rays. What are the things on which it depends? So it depends on the refractive index of the slab. It depends on the thickness of slab, and it depends on the angle of incidence, or it is directly proportional to angle of incidence. Okay. Is there any other thing on which the lateral displacement can depend? Can you think of any other thing on which the lateral displacement may depend?
The color of light.
Yes, the color of light. So the next thing, it depends on the color of light. And the color of light, we call in the scientific terms, we don't say it color, we call it the wavelength. So it depends on the color of light that we call as the wavelength. So these are the four factors on which the lateral displacement depends. Lateral displacement, it depends on the refractive index of the glass slab. It depends on the thickness of the glass slab. It depends on the angle of incidence and the color of the wavelength. Okay. Now, let us talk of, is there anyone having any doubt from this rectangular glass slab? Any question on this?
Sir, can we prove that angle of incidence is equal to angle of emergence?
Yes, angle of incidence is equal to the angle of emergence.
Sir, can we prove it?
Yeah, you can prove it. There is no hard and fast. Obviously, you can use the principle of reversibility of light. Okay. By the principle of reversibility of light, if you use the principle of reversibility, so if you place a plane mirror here perpendicular to this incident ray, it will retrace its path. So this will happen only if the angle of incidence is equal to angle of emergence. Another way is that if you find out the refractive index here. So let us say I find out the refractive index of glass. So I will get the value here sin I by sin R, right? Is this correct? Using the Snell's law, I will get the refractive index to be equal to sin I by sin R. Okay. Now here, now if I find out the refractive index at this point, so I will, to find out the refractive index here, I must use, now my angle of incidence is equal to the angle of refraction, that is R, and angle of R is equal to angle E. Okay, but if I find here the refractive index the same way, that will not be the refractive index of glass, because now the ray of light is traveling, the incident ray. See, I hope you are getting.
Yes, sir.
Okay. See, there are two refractions occurring. First refraction is occurring at the first surface, that is at the surface AB. You observe the first refraction occurring at the surface AB. Then we observe the second refraction. The second refraction occurs at the surface CD, at this surface. So for the first surface AB, we have obtained the refractive index of glass as sin I by sin R. See, when I say refractive index of glass, then I am observing the refracted ray is inside the glass. Okay. If I observe here at this point, so at this point I will say that the refractive index, now if I want to find out the refractive index the same way, so here I will say that the refractive index is equal to, again, sin I by sin R, but now my angle of incidence. Now my angle of incidence is equal to R, and angle of refraction is equal to the angle E. So I'll write here sin R by sin E. Right? Is it correct? Anyone having any doubt?
No,
But
sir.
here, the refracted ray is in air and incident ray is in glass. So I will not say that this is the refractive index of glass. I will say that this is the refractive index of air with respect to glass, not glass with respect to air. So the refractive index of glass with respect to air is 1 over the refractive index of air with respect to glass. So I must reciprocate on here. If I reciprocate on both sides, I will get here 1 over refractive index of air with respect to glass equal to sin R by sin E by sin R. Okay. So we get here sin E by sin R, and now this is equal to the refractive index of glass. So I can write refractive index of glass with respect to air is sin E by sin R. Now if I compare both the expressions of refractive index here and here, so can I conclude that I should be equal to E?
Yes, sir.
Yes. So then I can conclude that my angle of incidence is equal to the angle of emergence. So therefore, hence proved. Anyone having any other doubt from this last slab?
No, sir.
Okay. See, once you do it practically, if you go on performing this in a practical way, so if you perform this practically, what will you observe here? If you do this practically, so you will observe that if you place some object here, if you place any object here, and if you observe from this side, so that object will not be observable to you here. You will see that object not there, but you will see that object in a straight line of this. In a straight line of this, you will observe that object somewhere here. This is what we mean by the lateral displacement. It shows that the ray of light which was passing through the glass slab, it has actually changed its path. Okay. So this topic of rectangular glass slab, I think it is clear to everyone about the lateral displacement, about the angle of incidence, angle of refraction, the emergent ray, angle of emergence, principle of reversibility of light. Yes. What do you mean by principle of reversibility of light? Yes. What is meant by principle of reversibility of light?
Sir, when light is reflected, uh, it traces its own path again.
Yes. The light will retrace back its path if you place a plane mirror in perpendicular to it. So whatever path it comes, it will retrace its path. That is called as principle of reversibility of light. Now, this with the glass slab, we have completed the refraction part. There is one more that we have the relative refractive index. So let us say you have some questions which are based on relative refractive index and compound refractive index. See, the relative refractive index, it refers to the refractive index of a medium with respect to another medium. In the earlier cases, when we were studying about the refractive index, so we were taking the first medium to be air. Here, we do not say that the first medium is air. Maybe the ray of light travels from any medium to any medium. So you have here an interface between the two media, and we just have, now we do not say the first medium is air. We just know that this is your medium 1 and this is your medium 2. Let us say the ray of light has light has some speed v1 in the first medium and some speed v2 in the second medium. Okay. So the relative refractive index means we will define the refractive index of medium 1 with respect to medium 2, or we'll define refractive index of medium 2 with respect to medium 1. So here we observe that when the ray of light passes from medium 1 to medium 2, it gets bent towards the medium 2, towards the normal. To find out the refractive index here, we write refractive index N will be equal to V1 by V2. And this we call as the refractive index of medium 2 with respect to 1. So we write it as N12. See, either write it N12 like this, or you write it n, 2 and 1 here. So it is refractive index of medium 2 with respect to 1. We observe the refractive index of the medium where the refraction is occurring, in which the refraction is occurring. So here we observe that refraction is occurring in the medium 2 and not in medium 1. So we are finding the refractive index of medium 2 with respect to 1. This is equal to V1 by V2, and a very important relationship here. This is also equal to N1 by N2. Now what does this N1 and N2 represent? Here N1 and N2, they represent the absolute refractive indices. They represent absolute refractive index. It is the absolute refractive index of medium 1, and N2 is the absolute refractive index of medium 2. Okay. I'll give you one question based on this formula. Keep a note of this formula. I'm going to give you one question from. Have you noted the formula?
Yes, sir.
Okay. So here is the question. The refractive index of,
Once can you go back?
yeah, just one, let me first write the question, then I'll show you the previous slide also. You have the refractive index of water with respect to, the refractive index of water is 4 by 3. And refractive index of glass is 3 by 2. Find the refractive index. You have to find the refractive index of glass with respect to water. So this is what you have to do. Find the refractive index of glass with respect to water.
No, the previous slide.
Yeah, now you can see the screen here.
What is it?
Yeah. Okay.
Yes, sir.
So you have, okay, you have the formula. Now you can take the question, try to solve this out.
Sir, is it 9 by 8?
Sir, is it 9 by 8?
Yeah, the answer is 9 by 8. How many of you got 9 by 8?
I got 9 by 8.
Okay, how many
I
got
got
8
9
by,
by 8.
okay, how many got 8 by 9? Is there anyone who got 2 also, or 1 by 2? Okay, so you got the answer to this question, and the answer is 9 by 8. Okay. Okay, so bye all of you. We'll see you again in the next class. Do prepare for a test.
Thank you, sir.
Goodbye.
Bye, sir.